my supervisor, Professor Asaf. I'm here to present our work, software engineering and artificial intelligence, really enhancing the cycle. Now, before I start, I would like to say compliment of the season to everyone. So, as the topic said, software engineering and artificial intelligence will enhancing the cycle. That is, seeing how software engineering can be enhanced through the concept of artificial intelligence, and also the concept of artificial intelligence can be enhanced from a technique of software engineering. Let's start by introduction. The invention of integrated circuit by the Jack Bilby and the work of Burden and Walterhouse Britain has brought about what is called a transistor, which was among the things that brought the concept of personal computers, which led to, due to personal computers, which led to demand of softwares. And the demand of softwares, which the developers were not having cautions in development. They do not apply principles and guidelines. And also, they do not train their people in terms of software development. With they having a concept that where will they profile their people again after having the entirely all required know-how to do, but without concern of the mindful of that decision that they are taking, without concern of, without mirroring the present or latest engineering professional implementation and environmental, whether that development will it be favorable to organization, will it be favorable to environment, will it be favorable to the professional client that they are developing it, which the answer to those questions was no. So software engineering was being introduced by the NATO as a great achievement, which was successful and also profitable, which made automating business was not just successful but profitable. And it was nearly different with respect to malleability, that is flexibility. And so software engineering is yet to clearly give a formal method to the software design and development, but perhaps which AI may assist in conventionalization of the software design and development. So AI is encompass machine learning and deep learning. So AI keep on rising from the ability to give computer to act on a knowledge rules set to it, to machine learning, whereby computer is trained to learn in order to perform a given task. So during the 1950s, researchers were working on the new field AI, whether computer can think like human beings or computer can perform function like human beings. The most researchers in the area, in the AI, are concerned with its abilities for mathematics algorithm that make it capable to understand, perform, and improve from experience. While research in the SE deals with, that is software engineering, this would enable human beings with business tools or process to create software that meets the needs of business, perform the tasks efficiently and effectively, to be easy to operate, use, maintain, to accept modification, change, and do the changing for better and future enhancement. So the future of AI is worthwhile to research to see how influential it is to software engineering while avoiding the pitfalls. So the work, due to the matter of significant of time at that time, we are not able to insert our own personal experiment in terms of those enhancing the cycle, but we were able to submit some very good works through which we outline how artificial intelligence can contribute more on to software engineering. We're able to highlight how software engineering can contribute more to artificial intelligence. We emphasize to stakeholders in the software engineering and artificial intelligence sector to not just work on remaking the safety of autonomous vehicle, that is AI, but also to work on software theory for all technologies, such as AI that requires software to operate. And we are able to propose the need for professional bodies from most of the sectors like philosophy, law, doctors, engineers, government, international communities such as the NATO, science and technology communities to develop a professional approach, set up a high standard that is on the AI to work in the future that can guarantee safety and to be committed to the public interest. So artificial intelligence begins in the 50s which was expressed by the McCarthy and his colleagues, which they stated it in forward. That is, they concepted it in forward. Intelligence performance requires knowledge. So during the 1843, when Adelaide was invited by her colleague Charles Babbage to comment on his analytical engine to assist, she comments that the analytical engine was meant to assist in doing jobs, but quicker. But it can only do anything we know how to command it to do. So she said that it could not think. But she was contradicted by Alan Turing during the 1950s on his paper titled Computing Machineries and Intelligence. So the AI pioneer, that is Alan Turing, while presenting his Turing test, as well as key technicalities that the world come. Can you hear me? Hello? Hello?
Yes, go ahead, please.
You can hear me?
Yep, we can hear you.
Okay.
Yep, thank you.
So, while presenting his Alan Turing test, among the principles of the technicians that all came to the entangle of that word AI. So the pioneer came to the conclusion that computers could think. So among the principle of the AI procedure and the collection is that the advancement is sought by developing a system that does synthesize before analysis. That is, among those procedure and collection, in that advancement is sought by developing the system that does synthesize before analysis. So if you follow this concept or this analogy by categorizing it with how Amazon software, one of their AI projects, which failed due to this concept, because they wanted to build a project that will be screening applicants' seal, that is curriculum vitae, which the project failed as a result of bias. It started rejecting female due to some netballs in the hobby segment. So, and that project was failed because it wasn't analyzed, it was synthesized before analyzed. So in software engineering, AI is transforming natural language requirement into design and specification that can be used for description and data types in the programming. So also in terms of software engineering, there are some certain researchers who develops a class model builder, which is CM builder, that helps in building a class diagram specified in unified modeling language from natural language requirement document. Another one was AI knowledge-based system, which is used to capture design relatives upon the development of the needed input and output of a system activity. Another one initiated was oncology-based software development environment from software process existence. Another one is computational intelligence techniques, which was built to help and encourage requirement engineering through intelligence computing. Product line architecture, which defined to improve reusability and editability, which is very very useful in terms of technology, reusability and editability or modifiability. Don't just leave it at editability. I've mentioned architectures whereby you can reuse your architecture or you reuse your code, reuse your techniques, and they're likely to be applied to exemplify the class set of architectures. Expert system also can help programmers in coding and testing programs. Equivalent to analogical reasoning is also case-based reasoning that solves similar problems with similar solutions. Another one is experience factory, which for reuse and management of experience, knowledge, process, and product. Likewise, properly known as also learning software organization. There are reusable techniques such as knowledge acquisition and domain modeling. All are helping reusing and modification. Also, AI researchers have been committed also in application of constraint solving concept in automation of program testing. One of the things in the software engineering which AI will help is through this constraint-based testing, we can develop a software case or software case scenarios, testing scenarios, which makes testing easier. Another one is through the concept of meta-heuristic. Through the concept of meta-heuristic, we are able to develop search-based software engineering to help in searching. Also with pattern trace identification, detection, enhancement in Java, which also help in constraint programming. So AI researchers have been committed to the application of constraint solving, also such as techniques that can distinguish parallel features with many dimensions, including scope of the purpose of the address. So what power of level of automation and what portion level of cost from not formal requirement to machine learning is mechanized? Purpose of what portion of the system life cycle is addressed, and knowledge of what types of know-how information is used by the machine. So these are what artificial intelligence helps to distinguish in the parallel features with many dimensions, which is like the scope, the power, the cost from not just formal requirement to machine learning, also as it mechanized the purpose of what portion of the system life cycle is addressed, that is the life cycle, and the knowledge, what types of know-how information is used by the machine. So AI capabilities can be tested to be serving a purpose in software engineering, research, and implementation, which can be referred as either for both probabilistic software engineering, classification learning, and prediction for software engineering, search-based, and the likes. So probabilistic software engineering, which can be used for prediction, classification learning and prediction, used for classification or segmentation, and search-based, which can be used for search-based. So this just is structure which is universal, structure of artificial intelligence. Machine learning is composite under artificial intelligence, and deep learning is under machine learning. So artificial intelligence needs research from software engineering. So in order to standardize AI, we need to standardize AI as it keeps on rising. So we need research from the software engineering to systematically support the production of AI system applications, the operations in the real ecosystem, together with examining, maintaining, modifying to increase more features for more enhancement. And to do the discovery of the best among the better alternatives in terms of scientific, systematic approaches and methods, so that we can have a conventional models and architecture for AI application system. So software engineering domains can enable the description of AI application method and can serve as an information dictionary to all elements used in the development process. This can make an easy way in the future to have a universal software theory that can support the development of AI or other technologies, so that it will give room for legal framework in case if there is for breach of contract between customers and manufacturers or developers. So now let's briefly look at software engineering. So software engineering is a systematic approach application of mathematical techniques and scientific methods for developing, operating, maintaining, enhancing, and retiring of software at an affordable cost to the customer. So the discipline was introduced by the NATO, as I said. So the study found out that as a result of innovation of microchips, transistors, and integrated circuits that led to the affordability of personal computers to individuals, which turns lead to high demand of software, and high demand of software, which led to developers developing the software without care, without concern, with the might of after we develop a software and set it to operate, our task is finished, or the solely deployable function service for an achievement software project is functioning software. Meanwhile, the real existence and function of software is merely one segment of the software arrangement or setup that brings many components. So early beginning of developing software code, early beginning to developing software code, then the extension of the period to complete it done. That is developing the software code, then extension of the period to complete it done. Also, research from industry information discovered that from 60 to 80% of all tax expended on software expect to be spent after it is developed, after it is deployed to the client for the first time. So NATO discussions during the 1960s aim is to have an efficient and effective production way of high standard and mostly which software system. So the objective is to help and encourage software engineers and managers to develop credible software in a quicker way with tools, method, and discipline. So at that time, they were able to apply the tools, method, and process, which are the concept of engineering to software engineering. So the tools was to be either semi-automated or automated enablers for the software process and method. The method was a procedural, technical know-how for developing software, and the process was the glue between the technological layers together and the support rational and development of the software. So therefore, software engineering is a standard development of software, not theory. So there are many other arguments for the use of theories. Moreover, theories provide common frameworks that allow the structuring of knowledge in a precise and concise path that facilitates the communication of ideas and knowledge independent space and time. But nonetheless, the usefulness of theories for software development is at this moment a discussion issue, and current use of theories in this discipline is not well known. Even though Simon presented that more and more computers will program themselves during the time of great expectation for AI, but this expectation did not come to fruition at that time. So software engineering consists of methods. This is the structure of software engineering. So why we need research from AI? Why software engineering research? We need research from AI because as we are going into the Internet of Things, AI can make inclusion of those technologies more productive, as well as to serve as an ecosystem for testing software and models. This research can enhance the civic legal framework to raise up user acceptance. To raise up user acceptance, the method may be engineered using AI concept, which can lead to perceivable robust technology and can help in preparation of a data dictionary for describing the meaning of respective software engineering method and tools. In addition, other new AI techniques that are extending or trending in a virtual environment can be applied for a better variation of software engineering approaches. So this is a cross-section between software engineering and artificial intelligence. These are we have discussed. This is data. DM is data modeling. PM is project management, re-engineering, requirement engineering, designing engineering, and the key base is knowledge-based system, agent system, competitive intelligence, and so on. So as we need to create more software engineering possibility techniques that can enable rapid application development and evolution, we can apply the concept of software engineering to development of production project management, creation of requirement engineering also, designing engineering, software source code engineering, method models to enable the development of an intelligent system, as well as using advanced data analysis. Knowledge-based advancement can simplify to mix experience factory and reason atmosphere system like the data modeling advancement, which enables the development of models for generating the requirement for the system programs and service product lines. So between CBR and EF, the former is applied for accessing and information to the latter. So SE applied the concept of information agent to the model or replicate production processes or to share and show substitute requests. So the sophistication of AI is getting more value. That is what vital to examine how it is of assistance to software engineers while preventing the possible drawbacks. AI development, which can lead to high sum of preference, reasoning, autonomy, fit to crucial law and ethical issues whose solutions affect both experts and customers of the AI technology. Those issues climb between civil code of conduct, rules of law, public matters, and practitioner ethics, philosophical policy, and the likes that will require intelligences from the AI scientists or engineers, software engineers, legal practitioners, political analysts, and advocates to answer this. So even though nowadays customers is limited to sue for damages due to breach of contract in commercial off-the-shelf software. In fact, most of the cases end up discouraging the customer due to the inadequate professional standard in the industry. So how significant are we trying to ensure set of principles are put in place for customers to have confidence in the system for AI? Well, Vladek brought an example in the 2015 that if autonomous vehicle, that is driving vehicle, is being deployed in the country at that time, like US, to reduce approximately 4,000 yearly traffic inevitables and crashes in one of the two equal figures, then the manufacturers could get more than 2,000 damages lawsuit instead of thousands of feedback. He said that there will be thousands of lawsuits instead of feedback for appreciation note from the customers. But the question is, in what legal regulation or legislation capacity can guarantee the certainty of autonomous self-driving car or drone vehicle to be best possible? So due to lack of this standard, how sure that if the customer buy these technologies can have this way to sue for any legal action if he wants to? Because currently there is no professional body, even just not just AI in general, but just software in concept. Most of the cases in terms of software, the developers try to get away. But there is the law for customers seek for is right in terms of this. But some researchers propose that society will ignore autonomous technologies except there are some trustworthy ways of propelling them to where without saved. Okay, software engineering for AI can help. So that is the concept of software engineering can standardize for AI, can help to ascertain the indefinite areas in which an AI may indefinitely act as a desired equivalent to various fields of robustness research. An example of such software engineering concept to successful design and implementation of software is verification and validation. So let's just see verification. Verification is the process of confirming in order to substantiate that system is able to act what it formally requested to perform. Did we develop the system correctly? Verification mirrors the main approaches that assure a highly reliable set of formal conditions that AI software must satisfy to give room for legal framework and the likes. So if so, then the persuasion of AI and other automation technologies to scale critical safety measures and reach satisfactory set of affairs so that they can be acceptable to the society will be victorious. So verification through the concept of testing from software engineering. If we have good verification concept, it can also give confidence for AI. It can enhance AI to be more acceptable to the public. So verification difference between software engineering and artificial intelligence. So research shows that approximately when developing a technological device, the noticeable difference between software engineering and artificial intelligence in terms of verification is the outcome of this. Software engineering, which is software is implemented with thoughtfulness of a non-mathematical and machine model, while in contrast to artificial intelligence system, particularly robot that function in the ecosystem that is relatively known by the system expert. So in today's turbulent environment, that is an environment that doesn't have constant, always change, software engineering can come up with a model to give artificial intelligence a full support for universal acceptance due to the convention verification. So then another one is validation. Validation, this is a state of being authentic. Validation is to measure the system to see how it corresponds to its formal requirement by not having unacceptable features with repercussion. So did we develop the correct system? Validity measures is to affirm and ground unwanted attribute. That is to confirm and remove unwanted attribute that may exist, happen regardless of system is formally proper. In the future terms, research shows that AI system influential can have more capabilities and self-control. In such instance, unjustifiable validity could progress the huge damages. Healthy and wealthy assurance of machine learning methods, a field represented as for not long-term validity research will also be significant for long-term validity for safety. So through validation, if we can able to verify, it can give a room for healthy and wealthy assurance for the machine learning model. So other requirements and support for the creation of legal framework for AI. Through this, it can create a legal framework, like I said. So software engineering verification and validation can only allow for development of AI, whether autonomously or not, to absolute correctness level. But in case of if there could be a hidden unrecovered defect that can only be detected when the customer has almost spent more than a month using it, that defect could cause economic damages, crashes, and fatalities. So how can customers seek the restitution of those such damage? So even though verification and validation can give more enhancement of this AI, but in case of whereby a customer buys some certain AI product and after some certain month he have damages that cause him either fatalities or accident, how will he restitute for such damage? That is why the things bring the need for all communities and all professionals from the philosophy, from the law, from the science, from the health, to have a well professional approach and set up a high standard and be committed to the public interest. So the recommendation was, during the 90s, when car was being implemented, there was a lot of fatalities, there were a lot of damages. But when bunch of doctors, bunch of road experts, bunch of civil engineers, bunch of philosophers, bunch of psychologists came up, and the engineers and the automation engineers came up and brought up a legal framework, that was where the car and the road system came up to 99.9%. So if we want to enhance our software engineering and artificial intelligence, except most especially now that we are getting used to artificial intelligence, we need to have such bodies, such professionals, both from those angles, to come up with a framework that can protect the interest, the public interest, and also to have a bunch of professionals that can produce a good product for the society. That is the recommendation. So the conclusion as the techniques of AI and software engineering makes an impact achievement to software engineering, then we need to work more on software engineering for artificial intelligence, especially the concept of verification and validation. This is very important, verification and validation from techniques of software engineering, which can make the autonomous vehicle easy to implement to the market, as it can give AI qualities assurance to the public. As the people expect the ideal factor, artificial intelligence, to be a perfect autonomous vehicle that varies from what it is in the reality, and thoroughly check between the artificial intelligence and software engineering and find out more possible features of each segment and can be the solution to boost each other. Both of them can be a solution to each other in case if there are some certain few imperfections. So for us to be able to create an autonomous artificial intelligence and can work robustly accurate, then all AI communities must, of course, need to come up with a good attribute that can be applied to every domain. And the standard issues need to also find the solutions to questions like what software engineering formal abilities are currently available, how reliable are they, what kind of research should undertake to find more abilities and concepts, what concept can we interchange such that all fields of the computer science and broader artificial intelligence expertise can be made useful worthy. To exemplify this is to work with the work of Wallace and Allen 2008 that concern for substantial relevant factor is the logical value of a variety set of formal standard or ethical code of conduct. We may need to apply little word of approximation if formal standard cannot be organized well enough to influence behavior in safety critical state of affairs. There is nothing so practical as a good theory. So theories explain one specific aspect of reality. So maybe through the concept of software, if you can have a software theory that can, since AI is being dependent on software which tells you what to do, if we are able to have a good theory of a software whereby it explains what to do, how it do, when it do, according to what it is known from it up to the present time, the enable prediction future event. Today's software architecture is largely described as emulate to adopt. So there is need to accept. There is no accepted software architecture widely. Even the software architecture, we do not have a universal one. So not to talk of the software architecture for AI. So researchers need to do more between the software engineering and artificial intelligence to reduce artificial intelligence development time, effort, and cost, and also to have an acceptance software engineering model to artificial intelligence, that is AI, in such a way that it's not just only software engineering standard to AI, but conventional software theory and software architecture that can standardize the development of artificial intelligence and other technologies. So with the help of theory, since there is also a research now in software theory, so we can have a software theory, it could have make things easier, but not just software theory, but today's software architecture, we do not have universal software architecture. We are just using emulate to adopt. But if we can able to produce a software theory that can serve universal, telling us the prediction of how software will be, how it will do, when it will do, maybe it can be more conventional and can standardize the development of artificial intelligence with other technologies. Thank you very much. Anyone have questions?